Okay, let's have a look at 34 then. We've got the sum from r equals 0 to infinity of 2t minus 3 to the power r over 4. We want to find out whether this series converges, and if so, for what values of t it does converge. And we also want to find, in that case, what the sum to infinity is as well. So the first thing to do is to write out the term so we're familiar with this sequence as a GP. So let's put these 2t minus 3 to the r. The first term will be 0 over 4. Then the second term, 2t minus 3 to the 1 over 4. Then the third term will be 2t minus 3 squared over 4, and then it carries on in the same manner. So this is equal to then, this will be 1, anything to the power 0 to 0 is 1, so that's 1 over 4, plus 2t minus 3 over 4, plus 2t minus 3 squared over 4, plus dot dot dot. So that we can infer from this that a, the first term, is a quarter, clearly, and we're multiplying just by 2t minus 3 each time, aren't we? R equals 2t minus 3. Okay, good. There's a and r. So when is the modulus? So that would be 2t minus 3. When is that less than 1? Okay, so we got this problem with moduli here. Well, what we can do is we can draw this as a graph, can't we? So I'm going to do a little sketch of that. 2t minus 3. If I draw this as a straight line, like y equals 2x minus 3, it's gradient 2, intercept minus 3. So I have this line here in my mind's eye, and there's minus 3. But the thing is, it's a modulus, so on this side it will equal that value. But these values where the line here generated, so this is t, and this is the line 2t minus 3. But when it goes negative, that line, we have to do the mirror image to get the positive value. We drop the minus, don't we? So that is actually the line then. So it crosses at 3 at 0. So now we can draw the modulus because we've drawn the line in question. So when is that less than 1? When is this height less than 1? Here. Here's a height 1. So we can see from the plot that that would happen when 2t minus 3, for example, this line has less than 1. And this line here happens to be, it's the same gradient reflected, so it's a gradient minus 2. So this is the line minus 2t plus 3, intercept 3. Yeah? Because it's perpendicular to this line. No, it's not perpendicular, sorry, it's a mirror image of this line here. So there's not perpendicularity, it's minus 2. Okay, so that's that line there. Okay, so that happens also, so when that holds, and the other condition would be when this line, the minus 2t plus 3, is also less than 1. That's when this modulus lies underneath this height of 1, isn't it? So it happens when 2t, for this one, is less than, move the 3 over, you get 4. So t, divide by 2 both sides, you get 2. And on this side, it's minus 2t, move the 3 over there. Or rather, why not just move the 2t over there, read from right to left is greater than, move the 1 there, it's going to be 2. So this would tell you divide by 2t is greater than 1. So t must be between 1 and 2. And it cannot hit the value of 1 and 2 because r must be less than 1. So either this holds, it's greater than 1 here. So it's a strict inequality here because this was a strict inequality. So those are the values then. So t can be greater than 1 and it can go up to 2. T lies between 1 and 2. That's what the value is for convergence then of t. So let's find out what it equals. So let's get S infinity. In this case, S infinity is a over 1 minus r. The a is a quarter over 1 minus r, which is 1 minus 2t minus 3. More than one term, put a bracket. So the 1 can stay on top. the 4 can come down to multiply through the bottom row, but we'll just work out what the bottom row is first. So let's put a bracket here. And we've got 1 minus 2t minus 3. So the minus runs through the whole bracket, so it'll be plus 3. So that'll be 4 minus 2t, which is 1 over 16 minus 8t. There we go then. That's the sum to infinity is now this sequence. This is a tricky question here because it relied on solving this inequality, basically, this modulus. Let me just briefly go through that. This modulus, we can do a sketch of it. It's going to, the modulus equals the value itself, which is 2t minus 3. That's the definition of the modulus. So it equals that straight line on the axes there of 2t minus 3, gradient 2, intercept minus 3, which is that line there. So that modulus equals that line on that side, but once it starts going negative, the modulus flips sign, and when it's negative, it equals minus this value. So it flips it to minus that value, which would be 3 minus 2t, 3 minus 2t, because you run a minus through it to flip the sign. And that's of gradient minus 2 and intercept 3. And then we wanted to know, when is this modulus then, which is this line here, when does it have its values, when are they less than the value 1? Because that's what this is asking. Well, we have this little problem here. So it's either going to be this holds, so there's going to be a value here, which we got from this side, and there's a value where it can get to and not go beyond here, which we got from this side of the problem. We found it was between 1 and 2. Okay then, that's 34 done then, and we got S infinity as well at the end, didn't we? We worked that out. Okay, good, that's 34 done.